In this chapter, I'm going to talk about work, power, and efficiency. This module learning outcome is a work done and power. You must be able to define work done and power. Number 2, on completion of the topic, the learning outcome, students should be able to plot the force distance graph according to scale of the work done to lift a load by means of a cable. It can be a rope, can be a chain, of which the weight or the mass must also be taken into consideration. Number 3, you must be able to determine from the graph the average effective force, or is called effective tension, as well as the work done, and then calculate the power required. Number 4, you must be able to calculate work done and the power required against a resistance on a horizontal plane restricted to motion at constant velocity and applied forces parallel to the plane only. So constant velocity means there will be no acceleration involved, because when the velocity is constant, acceleration is 0 and the forces are balanced. Number 5, you must be able to calculate work done and power exerted against gravity, restricted to vertical motion only. Calculate work done and power exerted against an inclined plane or against slope without taking friction into account. So the problems or the calculation will be based on frictionless surfaces. Last one, must be able to calculate the work done by torque. Outline topics. I will do the first one, which is work done on a straight line. Work done on a straight line, the important terms. You must be able to define work done. Work done is defined as the product of a force and the displacement of its application in the direction of a force. When a force displaces an object through a distance, work is done. The SI unit of a work done is a joule. And at the end of calculation, we just use the capital letter J. The symbolical expression for work done is W. And since it has something to do with force that displaces an object, it will be force multiplied by a distance. So the SI unit of a force is a Newton, and that of a distance is a meter, and a Newton meter is equivalent to a joule. If a distance is not given in meters, you convert to meters. If a force's work is done against gravity and you are given the mass of the object, you multiply it by 9,8 to change it to newtons. Now, the rate at which work is done, that quantity is called power. The SI unit of a power is a watt, and the symbol is just a capital letter W. Power is how fast work is done, or the rate at which work is done. And the symbol to calculate power is P, equal to, it will be work done divided by time. Now, where there is work done, we can put the force multiplied by distance. As you can see, the second formula, there is force multiplied by distance or displacement of its application, and divide by T. Now, S over T is equal to V. Where there is S over T, we can put V. So another formula to calculate power is F multiplied by velocity, or it can be the speed of the object. There are 3 formulas. If you are given work done, you divide it by time. If you are given force, distance, and time, you can do it in this equation. If you are given velocity, you can use this equation. Now, work done, W stands for work done and is measured in joules. And T stands for time, is measured in seconds. If time is given in hours, time given in minutes, always change to these units, seconds. And the S will be a distance or a displacement, and it must be in meters. If not given in these units, convert it to meters. Now, if the work done is in joule and the time is in second, joule per second is equivalent to a watt. When there are losses, input not equal to the output, we express the losses in terms of percentages. How much of a percentage is supplied? Efficiency is defined as the ratio between the output work and the input work. Output is on the numerator and the input is on the denominator, and you multiply by 100. When you punch this on a calculator, you only multiply by 100 and you exclude the symbol. You only include it to your final answer. You don't insert it on a calculator. Let's look at the next slide. The next slide is the formula that will be used in final exam. The formulas that will be used in final exam. The formula to calculate or to convert from kilograms to newtons, which is W equal to mg, it will be given. Second formula is that this W is for weight equal to mass multiplied by gravitational acceleration. And the second W is for work done, the capital letter 1. It is equal to a force multiplied by a distance or displacement. And the third one, it is power, which will be work done over time. Where there is work done, you can put F multiplied by distance to get the second formula. Formula to calculate efficiency, it will be given in the exam is output over the input multiplied by 100. And the formula, if work is done against gravity, work done will be equal to potential energy, because this mg is W for weight, which is the force, and the height here will be the distance. So if it's done against gravity, you can simply calculate potential energy, which is also measured in joules, just like work done. Kinetic energy formula is half mv squared. It will be given. And this is the formula for mechanical energy, total mechanical energy. It will be sum of potential energy and the sum of the kinetic energy. Now let's go back to the example. This example is taken from the question paper of April 2021. The question reads as follows. A man is pushing a trolley with an applied force, and the trolley is moving with a velocity of 10 meters per second. Calculate the power required to maintain the movement of the trolley. This is a horizontal movement. A man is pushing the trolley that is moving at 10 meters per second. So first write down the givens. This is the force, so F is given as 500, V is 10 meters per second, and the P is unknown. Calculate the power. So the formula that involves the givens as well as the unknown will be this one, P equal to FV. In place of a force, you substitute 500, and where there is V, multiply by 10. 500 by 10 will be 5,000. The SI unit of a power is a watt. Now, if a question says calculate it in kilowatts, this answer will be 5 kilowatts because a kilo is equivalent to 1,000. Now, let's look at the second question. A crane is hoisting a load of 50 kg onto a platform which is 15 meters high. It requires an input energy of 8,050 joules. Calculate the efficiency of the crane. So it's hoisting onto a platform. So this work will be done against gravity. So when work is done against gravity, you can simply calculate a potential energy because mg will be a force and the height onto which the load is hoisted will be the distance. Now, when we write the given, the input energy, which is the Q in, for heat, we can use the symbol Q or E in for energy. It is 8,050 joules, and the height is given as 15 meters. The mass of the object is 50 kg. Now it says calculate the efficiency. Input is given. Efficiency is output over input. So we do have this energy. Now you must first calculate what is the output, what is the energy produced by the crane, because we have a motor that is driving the train, that is supplying the power to it or the energy to it. And that energy in is this one. So we must get the energy out. Energy out against gravity will be potential energy, which is mgh, or we can use force times distance. Mg will give us a force, and the height will give us a distance. So it's 50 times 9.8 multiplied by the height, which is 15. And the answer is 7,350 joules. Then we substitute into efficiency formula. Output is always less than the input because there are losses in between. Then you divide, you punch this on a calculator, multiply by 100. Remember, you not to put this in a calculator. And you just include your SI unit as an SI unit. The efficiency is 93,304 when you correct to 3 decimal places. So this is the work done against gravity, and the first question was work done on a horizontal plane, both taken from the question paper of April 2021. Our next topic will be the work done by torque. Thank you.